In this video, we will look at how to create a health system, deal damage, heal, and regeneration. So let's create a health system. Open Content Browser, right-click, under Blueprint, select Structure, and name it Health. When we work with health, we need to know three values. The first one is minimum, that is usually given by 0 value. The second one is maximum, so name it max health. You could use float type if you really want to work with decimal numbers, but I go with integer. The third one is the value in between current health and its integer as well. You can also change default values because you might forget to set it in the future, and starting values should never be 0. We have the health structure, so let's create a library so we can work with it easy. I have here a custom folder, right-click, Blueprint, select Blueprint function library, and name it stats, because I intend to make in it functions about any stats. Let's create getters and setters. Name new function get max health. Add input parameter, name it health and set it to our health. Drag out health pin and select break health. Here check only to show max health. Drag out execution pin, add return node and drag into it max health. This function doesn't change any value, so check it as pure. Add another function and name it get current health. Same as before, add input parameter and name it health. It copies the last chosen type, so it's okay. Drag out health, select break health, and leave current health pin. Add return node, drag into it current health, and check it as pure. Getters are done, so to the setters. Add new function and name it set max health. Add input parameter health of health type. Drag out health pin and this time select set members in health. Check max health and drag it into set max health node. Now it would change just copy of health, so select set max health, expand health, and check pass by reference. You can see that input health changed from circle to diamond that represents passing of reference. Add new function, name it set current health, and add input parameter health. Drag it out, set members in health, check current health, and drag it into set max health node. We can also make it better organized for our work. For getters, change category to health pipe get, and for setters, health pipe set. Hit compile and I will do quick showcase that it works on my character in my class BP third person character. I will just move to the end of begin play and add a new variable health of our new health type. Get health, and now you can see that when we write get, it shows our getters. Otherwise you would have to break hit result every time and code would be messier. I just print out the default values and values changed by our setters, and you can see it works. So delete the test if you did it as well, and let's show the health. Open your HUD widget if you don't have one yet. Just create a new widget and I will show you how to set it up later. Add progress bar and rename it to pb_health bar. I set position X and Y to 100 and size X to 400. Now we also adjust appearance, so increase percentage. I like slightly rounded corners, so to the background image, set draw S, the rounded box, all corner radiuses set to 5, alpha of outline set to 1, width set to 5, and rounding type set the fixed radius. Repeat the process for fill image, so set draw S the rounded box, all corner radiuses set to 5, alpha of outline set to 1, width set to 5, and rounding type set to fixed radius. Down under appearance, set fill color and opacity to red. I also want to see clearly if health is at 1% or 99%. But if we set it to 0.99, it shows it as 1. We can change it by adjusting the border padding. Border width is 5, so it should be 5, but not exactly. You can go with 4 or 4.5. I also like background white to be a bit transparent, so I set alpha to 0.6. Now let's make the health bar to show player's health. Go to Graph, create a new function and name it Update Health Bar. Add input parameter health and set it to health. We want to update health bar, so drag it in, out of it search for set %, and connect it with start of function. Out of health pin add get current health and get max health. Those values are integer, but percentage is in float, so the current health and max health add the float. The current health add divide, and the second pin connect max health. The output of division connect to in %, and we're done here. Hit compile and back to character blueprint. Here I have collapsed graph of setting up HUD. After HUD is created and added to viewport, we can do the initial update of a health bar. Drag in HUD, and out of its reference, we can call function update health bar. Connect it, add the get health, connect it with input health of the function, and hit compile. You can see that the default percentage of health bar is not full, and when we hit play, the health bar updates as it should, so it works. Now let's implement the damage and healing. Open content browser, I have folder interfaces, so I go into it, right click, blueprint, and select blueprint interface. Damage and healing should contain blueprints that has health, so I name it has health. Name new function take damage. Add input parameter, name it source, and change type to actor, because almost always you will want to know what did the damage. For example, if some environment can kill NPCs, you don't want to give XP to the player for it. Add another input parameter, name it damage amount, and set it to integer. You can change or add more input parameters later in your game development. For example, if you have damage type, ignoring defense, and so on. Add another function and name it take heal. Add input parameter, name it health amount, and leave it as integer. I also add source, but it's not as mandatory as in previous function. Hit compile and back to character blueprint. Go to class settings, implemented interfaces, and add our new interface has health. On the left side, expand option interfaces and implement those functions by double-clicking on them. Taking damage is basically subtracting taken damage from current health and setting it as new value of current health. Taking heal is basically adding the amount of heal to current health and setting it as new value of current health as well. After any change of the health bar must be updated. So just quick test that it works as intended, and it does. I deleted the test and now to how to make it better. These calculations are too basic, so go to library stats, add function and name it calculate and apply damage, because that is what it will do. Add input parameter health and type is reference to health. Add another parameter, name it damage amount, set type to integer, and it doesn't need to be reference. So, when you do damage, you want to get current health and subtract from it damage amount. If the result is less or equal 0, you have two options, so add branch and connect it to condition. If it's true, set current health to 0 because we don't want to operate in negative numbers and we might want to know the result, so add return node. Add output parameter, name it something like that, ? Set it to boolean type and check it as true. Copy-paste set current health with return node. If branch result is false, set current health the result of subtraction and return output parameter that set to false. Add function and name it calculate and apply heal. Input parameters will be similar as in previous function, so add input parameter health and type is reference to health. Add another input parameter heal amount, type it's integer and it doesn't need to be reference. When you heal, you want to get current health and add to it heal amount. We want to check if the result is greater or equal to max health, so out of input health, add get max health, connect it to second pin of greater equal check, add branch, and connect it. Add set current health. If the branch is true, set current health to max health value and add return node. Add output parameter, name it full health ? Set it to boolean and check it as true. Copy-paste set current health with return node. If the branch is false, set current health the result of addition and return full health as false. Hit compile and back the character blueprint. Delete those calculations and let's replace them. The event take damage, add calculate and apply damage. The health input goes get of our health variable and connect the damage amounts. After the damage is calculated and applied, update health bar. Similar for event take heal, add calculate and apply heal. The health input goes get of our health variable, connect heal amounts, and update health bar as well. Return variable of calculations are not important for now, but we can use it for printing some information. For example, take damage can print out if damage was dealt or if it killed the player, and take heal can print out if player was healed or is at full health. This is done, so let's create testing objects that will do damage and heal. Open content browser, I have here folder testing objects, right click, blueprint class, select actor, and name it BP_damage area. To make it visible, go to starter content, particles, and drag in P_fire. It goes sideways, so rotate it by 90 degrees on y-axis and add box collision. Scroll down to events and add on component begin overlap. Drag out other actor, search for function of our interface take damage and add it in. Set the damage amount to some reasonable value, I set it to 25. The source of damage is this actor, so add to it self-reference. Hit compile and let's create heal. Open content browser, move back to damage area, right-click, blueprint class, select actor again, and name it BP_heal. There is no default particle that looks like something that should heal, so add cube. I scale it to 0.05 for X and Y and 0.2 for Z, but you can make it larger. Scroll down and change collision presets to no collision. Duplicate the cube, rotate it by 90 degrees so it creates cross, and move both cubes a bit up. Add box collision and change box extent to be about the size of the cross. Scroll down to events and add on component begin overlap. Drag out other actor, search for the second function of our interface, take heal, and add it in. Set heal amount, I set it to 10, and source is again self-reference. This will be a pickable actor, so after take heal, add destroy actor that has target as self by default. Hit compile, go to your level and add it in. I add one damage area and scale it up a bit. And my heal actor is really small, so I move it up a bit and duplicate it multiple times. And let's see how it works, so hit play. Damage area does damage when we walk in, and it kills the player when health reaches 0, and heals are healing. The basic damage system is done, so let's create Regeneration System. Open Content Browser, move the folder where you have health, right-click, Blueprint, select Structure, and name it Regeneration. First variable is initial delay that tells after how long the regeneration starts. Set it to float. Add variable and name it frequency. This tells how often regeneration is done and leave it as float. Add another variable, name it restore per tick, and set it to integer. I set all default values to 1 and move back the character blueprint. Add variable, name it health regeneration, and change its type to regeneration. Hit compile and I change the default values. I set frequency to 0.1, so it's fast, and initial delay to 2, so it takes longer before regeneration starts. The preparation is done, so let's make it work. Create 3 custom events. The first one, name health regeneration start. The second one, name health regeneration tick. And the third one, name health regeneration stop. Let's do this one by one. Drag out execution pin of start, add set timer by event, and move it to right so there is enough space. The event goes output the delegate of health regeneration tick. Add in get health regeneration and break regeneration. Expand options of set timer by event so you can see all options. The time goes frequency, and we want to regenerate constantly, so check looping as true. After initial start delay passes, the time starts to count down, so to get true initial delay, from initial delay subtract frequency and the result connect the initial start delay. Drag out return value of set timer by event and promote it to variable. Name it health regeneration handle. And we can set its category to handles. That's all for the first event. Now to the tick event. Drag out execution pin and add calculate and apply heal. The health connect get of our health variable and heal amount connect with restore per tick of our health regeneration variable. After that, add get HUD, out of it add update health bar, and the health goes again get of our health. From calculate and apply heal, drag out full health, add branch, and connect it after update health bar. If the health is full, we want to stop regeneration, so the true add call the health regeneration stop, and let's implement it. Get health regeneration handle, and out of it add clear and invalidate timer by handle, and connect it with start of this event. The regeneration system is done, so let's make it work. First, move the event begin play, and to the end add call the health regeneration start. Now move the function take damage. I delete the testing to make it clearer. When we take damage, we want to stop regeneration, so add health regeneration stop to the start. And when the damage is done, we want to restart it, so to the end add health regeneration start. Taking heal shouldn't interrupt the regeneration, so nothing here. Hit compile and let's test it. We take a damage, and after a while, regeneration starts. We can take heal during regeneration, and it looks as it should. Taking damage before the regeneration starts resets it, so it behaves as intended. The last thing you might use is regeneration per second. Go to our library stats and create new function get regeneration per second. Add input parameter regeneration and set it as a regeneration. This is get, so check it as pure. Drag out regeneration and select break regeneration. We don't need initial delay, so uncheck it. Now we need to get how many times regeneration is called per second, so right click and add a divide. Connect frequency to the second input pin and the first one set to 1. The result multiply with restore per tick, and we want to return integer, so right click the output pin and select the integer. At return node, drag into it the result of multiplication and rename it to regeneration per second. I also set the category to regeneration. Add another function, name it set regeneration per second, and drag it into regeneration category. Add input parameter regeneration and check it as pass by reference. Add another input parameter, name it regeneration per second, set it as integer and uncheck passing by reference. Now it's up to you, because it depends how often you want to perform regeneration take the value of frequency. If it's once per second, set frequency to 1 and connect regeneration per second with restore per tick. If you want it more often, give me a second. Here we go. You can copy what you see and I will tell you how it works. First, set regeneration per second to local variable. Then I want to check if the desired regeneration per second is divisible by 4. If it is, set result of division as restore per tick and frequency to 0.25. If it's not, try if it is divisible by 3 and then by 2. As you can see, I want the regeneration to perform between 0.25 and 0.5 seconds. If none of these attempts were successful, increase desired regeneration per second by 1 and try it again. This will eliminate the numbers that are indivisible, the prime numbers. I also have here a condition for the worst case scenario, if I messed up the code as I did. When new values are set, I also print out what the new regeneration rate is. This function will work, but it will be better if the visual regeneration is constant, so you might change it later. Let's test it out, so hit compile and go to character blueprint. Open construction script, get health regeneration, and add set regeneration per second. If we want the regeneration to be 7, it will be set to 8, because 7 is prime number. If we want it to be 2, it will be set to 2. And if we want it to be 1, it will be set to 2. Everything works, so I delete the stain objects and unnecessary prints. And we're done here. I hope this video was helpful to you. If it was, give it a like, and if you want to see more videos like this, subscribe. Anyway, good luck with your project, thanks for watching, and see you in the next video.